So today we'll try to understand about Helm. So what is Helm? What is the purpose of Helm? Why do we need Helm? Okay. Helm in Kubernetes. Helm is basically a package manager for Kubernetes applications. Okay. Helm is a package manager for Kubernetes applications. It allows you to install applications on a Kubernetes cluster in a similar manner to Yum, APT for a Linux distributions. In Linux servers, in Linux machines, if you want to install some software, we will use package managers. Right? So package manager is abstracting the complexity of installing the softwares. Package managers is basically abstracting the complexity to install some softwares. Right? Similarly, if I want to install some application, I mean to say if I want to deploy some application in a Kubernetes cluster, we can use Helm packages to install the application. So Helm allow you to fetch, deploy, and manage the life cycle of the applications, like both third-party applications as well as your own products. So why we have to use Helm? What is the complexity or what is the problem to deploy the applications in a Kubernetes? So Kubernetes can be difficult to manage with all the objects that you need to maintain. Suppose if you want to deploy application in a Kubernetes, what are all objects you need to create in a Kubernetes? Like you may need to create a lot of objects, right? Lot of Kubernetes objects. You may need to create deployment. You may need to create service. You may need to create a PVC, sometimes PV, HPA, config map, secrets. Right? If you want to deploy some application, just if you take only one application, if you take only one application, one image, right, one application, right, you may need to create a deployment. You may need to create a, for this image, for this application, you may need to create a deployment. You may need to create a service. Sometimes if your pod requires a volume, you may need to create a PVC. If you may need to create a PVC if your Kubernetes cluster doesn't support dynamic storage, you may need to create a PV also. Right? And you may need to create a config map, secrets, HPA. For your application, you may need to create a lot of Kubernetes objects. Right? Kubernetes can be difficult to manage with all the objects that you need to maintain. Basically, Helm manages all these for you. Helm manages all this for you. Helm simplifies the process. Basically, Helm simplifies the process of creating, managing, and deploying the applications. Helm simplifies the process of creating, managing, and deploying the applications using Helm charts. We call it as a chart, Helm chart. So, Helm will simplify the process of deploying the applications in a Kubernetes cluster and managing the applications in Kubernetes, right? Helm also maintains the version history of every application, every chart. Helm also maintains a version history of every application which we are going to deploy in a Kubernetes. It will maintain the versioning. If something goes wrong, you can simply call Helm rollback so that it will roll back to the previous state. It is like a deployment rollout rollback. Suppose if you want to upgrade, if you want to update your application, right? If you need to upgrade your chat, you can simply execute Helm upgrade so that it will update the application which is running in a Kubernetes cluster. So deploying applications to the Kubernetes can be complex. Deploying applications to the Kubernetes can be complex. Setting up a single application, deploying a single application involving creating a multiple Kubernetes resources, we may need to create a multiple Kubernetes resources as I already discussed, such as pods, services, deployments, right? And replica sets. So far, how we used to deploy this one? Suppose you guys are trying to deploy some application like Java application, Java web app. If I want to deploy this one, I may need to create a deployment. I need to create a service. I need to create maybe if required HPA, some Kubernetes objects. How we used to deploy so far these applications, like what we have written? So each requiring you to write a detailed manifest file. We have written our own manifest file. We have written the manifest files, right? You you need to create a manifest file from the scratch. You have to write a Kubernetes manifest files for your applications to be deployed. Suppose you have very big application, it is complex to write everything from a scratch, the YMLs, right? And also if something is getting updated, I need to update the YML instead of rather than passing values at runtime. I need to update a YML and again I have to apply that YML, whatever YMLs are getting modified. So to overcome this one, we have a Helm. Helm is basically a package manager for a Kubernetes. If I want to deploy some applications in a Kubernetes cluster, I have a Kubernetes cluster, I want to deploy some application, either our own application or third party application, we can use Helm. Basically in Helm, we have three concepts: Helm charts, Helm repositories, and Helm CLI. Helm composed of three components. Helm composed of three components: charts, repositories, and CLI. Then what is Helm chart? Helm composed of basically three components: Helm charts, repositories, and CLI. So what is Helm chart? Helm chart is basically collection of manifest files. Helm chart is basically collection of manifest files. Again, it's a YMLs only. It's a Kubernetes manifest. Helm chart is basically a collection of manifest files organized in a specific directory structure. Helm chart is basically a collection of manifest file organized in a specific directory structure that describe a related Kubernetes resource, right? Basically, Helm chart is nothing but a collection of YMLs. You have all the YMLs, like you have some specific directory structure like this. You will have your deployment.yml. If you want to deploy, you will have a service.yml for your application. You have hpa.yml. If you want to create a hpa, you can have service account. If you want to create a service account for this application, if you want to create a role, you can have a role related YML files, right? If you want to create, right? Basically, your Helm chart is nothing but a collection of manifest files organized in a specific directory structure that will describe some Kubernetes resource. Helm chart is nothing but collection of manifest files, YML files, organized in a specific directory structure. These YMLs describe some Kubernetes resource. Like Kubernetes resources are objects like deployment, service, etc. There are two main components again in a chart. In a Helm chart, there are two important components: templates and values. There are two main components in Helm chart: templates, and you will have a values file. So these templates are nothing but which we want to deploy. This template contains all the YML files which whatever you want to deploy for that application. So that along with the templates, we have a one more component called values. So these values YML is like a variables. Like this values file, it's like a variable file. We can define key value pairs. It's like a variable file, values file. We can define in a key value pairs, which can be referred in your template files, which we can refer in a template files. Basically, you can define values, key value pairs. It's like a variable file. We can define key value pairs. These values can be referred in template files. So Helm will render these values at runtime, right? So we have a templates and we have a values. These templates and values go through template rendering engine. So it will produce a manifest that is easily understandable by Kubernetes. At runtime, we can change values. You no need to modify your YML file. Suppose in YML file, I can refer a image name, image version from values file. I can change values file without modifying or without touching. It's like a templating. So these templates and values go through template rendering, and it will produce a manifest file, YML file that is easily digestible by Kubernetes. Basically, Helm uses basically charts to pack all your Kubernetes manifest for an application. Basically, Helm chart is nothing but we are going to pack all our Kubernetes components manifest for an application to deploy in our Kubernetes cluster. Helm charts are very similar to RPM and Debian packages, guys. You guys are using yum install, apt install, right? You guys are already using like package managers, like Linux package managers. We are using yum install, git, something like this. If it is a Linux, Debian or Ubuntu, we are using something like this, apt install, whatever software. What is happening in the background? This is package manager, right? So it will reduce the complexity. It is hiding the complexity. It is hiding the complexity of installing this software. The package manager will execute lot of things in the background. We are just executing this one, but this package manager will execute lot of scripts, lot of commands to install this software, right? Similarly, in a Kubernetes cluster, I can have a Helm chart. Excuse me. I can create a Helm chart. I can create a Helm chart and I can define all whatever manifest which I want to deploy for that application, deployment, service, SPA. So this Helm chart I can deploy in Kubernetes application, Kubernetes cluster, something like this, Helm install, your chart name. So it will deploy all the templates, all the manifest, whatever you have created for that application. And it will support templates, I mean to say values. We can change the values at runtime when we are installing the application. Helm chart pack all our Kubernetes components manifest for an application to deploy. Basically, Helm, as I already told, Helm packages or Helm charts are nothing but it consists YML files. It consists of YML files, whatever you want to deploy for that application. So Helm charts are basically consist of YML configuration files and some templates that are rendered into a Kubernetes manifest file. So this is the directory structure of Helm chart. If I create a Helm chart, there will be a folder for chart. Inside that folder, you will have a chart.yml, you have a charts folder, you have a templates folder, and you have a values folder. So template folder, we are going to have all the manifest files which is required for your application to be deployed. Within this templates folder, you are going to have YML files which is required for your application to be deployed. And values, we will define a values which can be referred in a templates. We can define values which can be referred in a templates, these templates. This chart YML, this chart.yml contains information about this chart name, version and description, metadata of this Helm chart. Suppose you have to deploy another chart. If you want to deploy another chart while deploying this one, that chart information we can maintain inside this folder, dependent charts, or we call it as a umbrella charts. Umbrella chart is nothing but you are deploying one Helm chart, one application. Along with that application, you want to deploy another application, dependent application. Like dependent application, right? Which we can define under the charts folder. It is not a pie chart or Helm chart. You are not generating the reports. I am saying you have a YMLs, right? Kubernetes YMLs. It is not like a pie chart. You are not generating the reports. Helm chart contains the YML files. That's what I am saying, right? Helm chart packages all the required Kubernetes manifest files. You are not generating the reports. It's a package. It is not a report. So the dependent charts I can define in this fold. So here we have a charts folder, right? This charts folder, we have a chart.yml that is about the information about this Helm chart. What is the application you are trying to deploy? What version of Helm chart, right? You can maintain the versioning in the Helm chart also. And the chart folder contains the dependent applications which you want to deploy along with that. And we have a templates folder, as I already told. This directory contains contains the files that are combined with values and Kubernetes manifest. So we are going to define all our manifest files in this folder. These templates are nothing but your Kubernetes YMLs. And also, what is the one more advantage? It can refer the values from values file. These values we can change while deploying a Helm chart also. At runtime also, you can change the values. So Helm chart is nothing but YML files for our application, which we are going to deploy using Helm. Helm, we can install our applications using Helm from a local directory. From a local directory, you can create a Helm chart directory and you can deploy directly using that local directory, or we can package that Helm chart as a tar file and we can deploy using the tar file, or we can maintain these Helm charts in a repository, Helm repository. We can maintain these Helm charts in a repository, Helm repository. The way we have a Docker repository, Docker images, we are going to maintain. Similarly, we are going to maintain Helm chart, complete YML files, guys. It is consists of only YML files, your Kubernetes YML files. We are going to maintain that information as a Helm chart that we can maintain in a Helm repository. We can automatically download and install charts from the repository also. So we have three components, as I told. Helm chart, basically Helm chart, Helm repositories and Helm CLIs. Chart is nothing but our Kubernetes YML files and its value files. Repository is nothing but where we are going to maintain the Helm charts centrally. Helm repositories are basically where the Helm charts are held or maintained. So basically, these are nothing but a set of templates and values stored as a code. So whatever application you want to deploy, you can create a Helm chart and you can maintain that Helm chart in the repository. We can add a Helm repository and we can install the application using Helm repository, something like this. We can deploy, basically we can deploy any application, our own application or our third party application using Helm repositories, Helm charts, right? If you see, already most of the applications are available as a Helm charts, right? Last time when I deploy Nginx ingress controller, how did I deploy it, guys? Did I use Helm chart or did I use lot of YML files? Did I use YML files to deploy? Basically, lot of YMLs we applied, right? How did I deploy it? Nginx ingress controller, lot of YML files, right? We are having a lot of YML files. We deployed using YML files, right? If you see the metric server, this metric server also what we have done, we have a lot of YMLs. If you see, we have a service YML, deployment YML, role, right? We have a service account, we have a cluster role, lot of objects we created. So these applications also, these softwares also, I can deploy as a Helm chart, right? Instead of maintaining something like this, I can create a Helm chart. I can deploy using Helm chart. If you see Nginx also, Kubernetes ingress, we have lot of YMLs. We are maintaining YMLs, something like this, and we are applying all these YMLs. Can I, if I use these YMLs, can I pass something at dynamic? Can I change the values? Like here, I want to change this value at while deploying. Instead of true, I want to make it as false, right? This value, or maybe here in a service or deployment or daemon set, I want to pass some environment variable at runtime. I don't want to hard code. Maybe the image version I want to modify while deploying. I don't want to modify YML. Can I pass at runtime? Is YMLs are having a template support as of now, which I can change at runtime. So if I use Helm, right, there is a template support, templating. I can define values in a values file, which I can refer here. While installing a Helm chart, I can modify the values. While installing a Helm chart, I can modify the values so that at runtime, we can pass values to the templates. So instead of deploying like this, I can use a Helm chart. I can use a Helm chart. All the applications are already available as a Helm chart, right? If you see, so lot of applications are already available as a Helm charts. If you see Nginx, right? Helm charts, Nginx Helm chart, right? You can see lot of, this is also available as a Helm chart. I no need to download all those YMLs. If you see the already they have created a chart, Helm chart, right? They have already created a Helm chart. I just need to add this repository. They are going to maintain the charts in their repository. So they are going to maintain the Helm charts in their repository, right? So this is where they are maintaining the source code as a Helm chart. If you see, so here they are maintaining the charts. If you see, there is a values.yml, there is a templates folder. It contains deployment file, deployment. And what is this, guys? Here they have not hard coded the names. What is this? If you see here, the chart name, image name also they have not hard coded, image name and version also they have not hard coded. Where did they define this image name, image tag and version? Where are these values has been defined? If you see, they have not hard coded this. We call it as a template, Helm template. We are creating a deployment basically, but values are not there here. Where are these values? These values comes from a values file. There is a values file in this Helm chart. Here we are going to define, right? If you see image repository is this, right? Tag is empty. If it is empty, it will take latest, right? So key value pairs, service, what type of service, port. Now these values has been referred in the templates. These values has been referred in the templates. If you see here in this Helm chart, in this templates, service file also there. If you see values, what type of service we have to create, they have not hard coded. Suppose tomorrow instead of cluster IP, if I want to create a load balancer type of service, I no need to touch this file. I no need to touch Helm charts. I can just update values at runtime and I can install this Helm chart, right? Basically, template folder is nothing but all your YML files, whatever is required for your application. Whatever is required for your application. And the values are basically which you are going to inject for your Helm chart, your templates. This contains just information. What is this? Your Helm chart is, chart.yml contains information about your application like version, right? Where are the sources? So this Helm chart contains basically all the information about your YML files. This, if you want to write some functions, right? By default, Helm supports lot of functions, right? If you if you want to write your own functions, right? Conditions, right? You can use these files. You can write Helm, TPL files, template files. It is like a function. You can, extend the Helm functionality. If you want to extend using your own functions, you can write, right? But this is not required in most of the cases. Already Helm has lot of functions which we are using in our templates. If you see in our templates file, right? If you see, this is one function. It has some meaning. By default, the Helm have this function inbuilt. And if you see, this is one condition we are checking if, right? Let me go to HPA. If you see, this is one function, right? If each and every this function comes with inbuilt. Now, if you see, this is kind of if else condition. If this is true, then only this will be generated, right? So this comes with inbuilt. This comes with inbuilt these functions. If you are trying to customize something which is not there inbuilt, you need to write this file. But in most of the cases, you no need to write these helpers, these functions, right? If you see, like we are extracting or we are expanding the Helm functions, right? So basically, we are using a templates in this chart and values we are injecting as from the values file. So this is Helm chart. Suppose if I want to deploy Nginx, I no need to do lot of stuff. What I can do? I can just add a repository, something like this. If I have a Helm installed, right? Helm CLI. If I have installed Helm CLI, I can execute this command to add a chart, and I can just install something like this. I can just need to I can add Helm repository. I can install the chart which is part of this repository, which is part of this repository. I added a Helm repository. I am installing a chart which is part of this repository. Helm is nothing to do with your Kubernetes flavor, like whether you are using self-managed, whether you are using cloud managed. Helm will work with any type of Kubernetes repository, Kubernetes. Guys, most of the Kubernetes concepts will, there is no change in the Kubernetes concept which based on the, Kubernetes cluster you are using. You are using self-managed or cloud managed, right? The Kubernetes concept remains same. But if I go for a cloud managed, what is the only advantage? Again, I am repeating because don't get confused. Helm is only for EKS, not like that. Okay. Helm is not only for EKS. Helm is for every Kubernetes cluster. Whether you are using EKS, COPS, QVDM, GKE, AKS, there is no change in the Helm concept. Helm is basically a package manager for Kubernetes cluster. That's it. So I can add a Helm repository and I can deploy the application. If I don't have a Helm chart already, for our applications, we will not have a Helm chart. For our applications, we need to create a Helm chart ourselves. For our applications, if you don't have a Helm chart, you can create a Helm chart, and if required, you can maintain that Helm chart in a GitHub as a source code, or you can package it as a tar file and you can maintain in a Helm repository. The last one is Helm CLI. What is the use of Helm CLI? Right? We can use Helm CLI to install the applications using Helm. Right? Helm is not for a documentation purpose, guys. I told Helm is a package manager. You are going to deploy the applications using Helm. It is not like you are documenting. You are going to use Helm to deploy your applications. From last 40 minutes, I am saying this. And still you are asking the question. It is, am I documenting anything here? Are they documenting anything here? Let me show, let me show this. Excuse me, guys. Are they documenting anything here? This is one Helm chart. Are they documenting anything here? What the chart has? Your chart has your deployment file which you want to deploy. The chart has your service file which you want to deploy in a Kubernetes cluster. The chart has HPA. If you want to deploy HPA, there is a HPA file, right? Helm chart is basically the YML files for your applications which you are trying to deploy. We are not documenting anything here. Okay. So now let's try to understand architecture, right? So Helm, basically there are two types of Helm versions initially. There are two types of Helm versions, right? Helm 2 and Helm 3. Basically, what is the primary difference between Helm 2 and Helm 3? This is very important. In recent interviews, they are asking what is the difference between Helm 2 architecture and Helm 3 architecture. So in Helm 2, let's first understand Helm 2. Basically, we have three things. Your Kubernetes cluster, you have Helm client, Helm CLI, and you have a Helm repository. Kubernetes cluster, Helm repository, and Helm CLI. So this Helm CLI, Helm client, can be installed in any machine. It can be in a developer machine, Helm CLI. It can be in a CI/CD server. What is the purpose of this Helm client? This Helm client will connect to the Kubernetes cluster and deploy the application. This Helm client will connect to the Kubernetes cluster and deploy the application. At high level, we have three things: Kubernetes cluster, Helm repository, and Helm client. But what is the difference between Helm 2 and Helm 3? If you see in Helm 2 architecture, in a Kubernetes cluster, we need to have a server side component called tiller. If you see this one, right, in Helm 2 architecture, in server side, I mean to say in a Kubernetes cluster, Helm cannot directly talk to the API server. It requires one more application called tiller. In Helm 2 architecture, this Helm CLI will connect to the tiller. It will contact tiller. Tiller will contact the API server and deploy the application, the Helm up, Helm chart. What do we have in a Helm repository, guys? What do we maintain, right? In the Helm repository, this Helm CLI can download the Helm charts from the repository. Then it can connect to the Kubernetes cluster and deploy the Helm chart. But in Helm 2 architecture, there is a server side component called a tiller. There is a server side component called tiller. When it comes to Helm 3, we don't need a server side component. Helm directly connects to the API, Kubernetes API server, and it will deploy the Helm chart. So this Helm CLI machine can be developer machine or DevOps guy machine, or it can be a Jenkins server. As part of CI/CD also, you can deploy the applications to the Kubernetes cluster using Helm chart. You can maintain your Helm charts in a GitHub, or you can maintain your Helm charts in a separate Helm repository. right? So using Helm, we can connect to the Kubernetes cluster and we can deploy the application, Helm chart. The chart is nothing but a YML files, your YML files. Right? So here in Helm 2, you need to deploy a tiller application with a service account. Tiller is basically one application. That application has to be deployed. For that application, for tiller, you need to have a service account. That service account should have a admin permission, because this guy will connect to the API server and deploy the application. If this tiller doesn't have a permissions to deploy, the tiller doesn't have a permissions to create deployment, the tiller doesn't have a permissions to create a pod, the tiller doesn't have a permissions to create service, will it able to create, will it able to talk to the API server and deploy? No, right? So that's why tiller application is created with a service account. That service account is associated with some role. That role has a permissions, cluster role, so that it can deploy. So as of now, the latest one is Helm 3. We are using Helm 3. We are not using Helm 2. We are not using Helm 2 architecture. When they introduced Helm, they have introduced with this architecture, Helm 2. Now, the latest version of the Helm is Helm 3. We don't need a tiller in a server side. You can directly, your Helm CLI can directly connect with Kubernetes cluster and it can deploy the application. But what is required in your Helm CLI, this Helm client, right? It is going to use kubeconfig file. If I want to install Helm here, this Helm should also have a kubeconfig file. The kubeconfig file has the information to connect to the Kubernetes cluster. When I am installing Helm 3 in this workstation, along with your Helm CLI, you should have a kubectl configured with kubeconfig file. So if this developer kubeconfig file doesn't have, this developer doesn't have a role which can be deployed applications. So again, Helm cannot deploy, because Helm is going to use the kubeconfig file, basically the kubectl, which is configured in this machine. If that guy doesn't have a permissions to create a pods deployments, again, when you execute Helm install, it will not work. So in Helm 3 architecture, we don't have a tiller server side component. Okay. So now let's install Helm 3. What is the prerequisite for to install Helm, to deploy the application using Helm? As I told, the workstation in which you are trying to install Helm, what we need to have? We should have the kubectl configured with the kubeconfig file. So if I want to deploy the applications using Helm, I am going to install Helm CLI. In that server where you are installing Helm, should have a kubectl with kubeconfig file configured. So I already have one machine where we already configured kubectl. Let me connect to that. Let me connect to this machine where I have configured kubectl. Now if you see, as of now I have a kubectl configured. This is pointing to this cluster, this API server, right? I have a kubectl configured, and this is configured with admin root account. So I am able to perform all the operations. I am able to perform all the operations. If you say I'm able to get, update, delete everything. So here, if I want to deploy some applications, right? So far we used to use YML to apply. We used to apply the YML files. Now if I want to deploy using Helm, right, I need to have a Helm CLI installed. If I want to deploy some application using Helm chart, or if you want to create a chart also, you should have a Helm CLI. As of now, I don't have a Helm. So let's install Helm software, right? I am going to download the script, one shell script, which is written by Helm. Now, I downloaded one script, this script. This has commands which will be executed to install the Helm CLI. Now let's change the permissions. Now let me execute this one. Now Helm is installed. If you see, Helm is installed. These are the commands, right? Helm commands. We have these commands. If I want to create a new chart, I can use this chart, right? If I want to add a repository, if chart is already part of repository, Helm repository, you can add a repository and then you can install, right? So these are the Helm commands which you can use. If I want to create a chart, I can execute Helm create. It will create a chart and we need to add all our YMLs values for your application. If the chart is already there in the repository, I can add a repository and I can install the Helm chart from the repository. So as of now, I installed Helm. So Helm ls. Basically, Helm ls will try to list any applications which is running already, which is installed already in the Kubernetes cluster using Helm. If I execute Helm ls, what it does basically, it will list all the applications, whatever has been deployed in the Kubernetes cluster using Helm. Did I deploy any Kubernetes, did I deploy any applications in a Kubernetes cluster as of now using Helm in any namespace? Did I deploy any application using Helm as of now in the Kubernetes cluster using Helm? We have not deployed anything. If you see, Helm ls will display the applications which we deployed in a Kubernetes cluster. As of now, we have not deployed anything. Guys, if you are getting this warning because this file is not secured, I mean to say, I think permissions are too wide. Let me change the ownership. Chown EC2 user, EC2 user, recursively, whatever is there in the dot cube. So we are getting this warning because the permissions are too wide. So I have changed the ownership only to EC2 user. Now, let me change ch mode So now I have given only full permissions to the owner, right? So let's now if you see, none of the applications are deployed using Helm as of now in this cluster. So Helm is using what information? Helm is using this kubeconfig file internally. It is using this kubeconfig file connecting to this Kubernetes cluster to deploy or retrieve the information. As of now, we have not deployed any application, Helm LS. Similarly, we have a Helm repo, Helm repositories, right? If you see, we have these commands, right? For Helm repo, I can add a repository, Helm chart repository. I can list the repositories. I can remove the Helm repositories, or I can update the charts from the repositories, right? I can take latest, I can update. It is like a update, apt update. Okay? Like you are updating your repository. If there are any changes in your chart in the repository, it will update. As of now, I have not added any repository. If you see Helm repo ls, there are no repositories added. If the charts are there in a Helm repository, I can add a repository something like this. I can add a repository something like this. Helm repo add. This can be anything. Your Helm repository name. So this is public repository. Public Nginx Helm repository. What are they maintaining in this repository, guys? This is public Nginx Helm repository. What are they maintaining here? What are they maintaining in that repository? Guys, it is not about image. Helm, they will not have a Docker image. In the Helm repositories, we will not have an image. Helm repository contains only Helm chart. Helm chart is nothing but a templates and values. Helm chart is nothing but a templates and values. The template contains all the YML files for that applications to be deployed. The template contains all the YML files for that applications to be deployed. The value file, basically, the values which you are going to refer in a template. So I can add a repository, Helm repository, then I can install that Helm chart. This chart is part of this Helm repository. If required, I can add a Helm repository, something like this. I can deploy Helm chart repository, or I can deploy Helm chart from a local folder. I can create a Helm chart locally and I can deploy the application. Or if the chart is already part of repository, I can add a repository, something like this. Helm repo add. This can be anything, guys. This can be ABC also. You can give ABC or XYZ, whatever. This is the URL of Helm repository. Now, if you see, I have added one Helm repository. Inside this Helm repository, there might be a lot of charts, right? You can search Helm search. Helm search repo. It is other way around. Helm search repo. If you see, what is this? What information it is displayed here? I can search only some specific repository. Suppose if I search something like this, whatever I have added, what is this, guys? I have added one repository. I have added one repository. This is my Helm repository name, which I used while adding. And when I am searching something like this, Helm search repo, I can give this repository name, or if I don't give, it will display all the charts in all the repositories. Helm search repo. What is this? This is Helm chart. This is Helm chart. This is chart name. This is chart name. This is your repository name, which you have added just now. Which you have added just now. Now, if I want to deploy this chart, I can deploy. What is there in this chart? This chart contains basically all the YML files which is required to deploy what application, guys? This chart contains all the YML files and values files which is required to deploy what application. If I execute something like this, Helm install, something like this, this chart name, I can give an application name, something like this. What this chart contains? This chart contains all the YML files, the value files which is required to deploy your application. So you can install something like this. But this is it a third-party application or is it our own application which we are trying to install now using Helm? Is it a third-party application or is it a own application? Our own application. It's a third-party application, right? So the Nginx as an organization, they have created a Helm chart also. We can install Nginx using YML files or we can install using Helm chart also. Again, don't get confused, guys. Helm chart is again nothing but a YML files, collection of YMLs, collection of templates. So nowhere I am able to see the YML files here. Those YML files, right? Those YMLs are part of this Helm repository, Helm chart. If you really want to see what are the YMLs which are part of this chart, you can do something like this: Helm template, your chart name. If you see, if I execute something like this, Helm template, the chart name. We have not installed as of now, just I am seeing what and all there. So if you see what are going to be created, if I install this chart, if I execute Helm install this chart, what is going to be created? Do you see a service account is getting created? Do you see that service account YML file? And do you see secret? Do you see config map? Whatever we have applied manually, guys. And do you see cluster role? Service account is binded with this cluster role binding. Do you see cluster role binding? And do you see a service for our ingress? What type of service they are creating? Load balancer. Deployment. So earlier when I deployed this one, how I deployed this application, I have taken all these YMLs and I applied. Now all these YMLs are part of this template, this chart, Helm chart. This Helm chart. If I install this application, it will create a service account, it will create a config map, secrets, role binding, deployment for your ingress. So last time we were maintaining all these as a YML files and we are applying. Now I can deploy the same application using Helm chart also. So as an Nginx as an organization, they created a Helm chart. If you see, these are the YMLs I can see there. But here they are referring from a values, right? Those values also part of your Helm chart. If you see, there is a values file. Do you see these values, right? Values file. These values are rendered when we are trying to install the application using Helm chart. Now I can install this one, which I already have, Nginx. I don't want to install. Similarly, you can add another repository, public Helm repository, something like this. Now, if I see Helm repo ls, I will have two repositories. I think I have not added. Error is no longer available. Try with this. Okay, so I have to try with this. This is no longer available, so maybe I need to update the document. Helm repo, add. Guys, here I can give anything, guys. I can give ABC also. Your repository name here to the Helm CLI. So let me give something like this. Repository name as table, that's it. Instead of this, I can give something like this, public Helm repo, whatever. The repository name I am giving as a stable, and this is my URL, Helm chart, Helm repository URL. Now, if I see how many repositories I added as of now to this CLI, there are two Helm repositories. Now, if I search Helm, search repo, now these many charts are there. These many charts are there, Helm charts. This Nginx ingress is from which Helm repository? This chart is from which repository? This chart is from this repository. This chart, this one is from this repository. Now all these charts, all these Helm charts are part of which repository? The second one, this one, from this repository. Now, if you see all the application, most of the applications already, the third-party applications is part of, it's available as a Helm chart. Now, if you see, I want to deploy cluster autoscaler, AWS cluster autoscaler, there is a Helm chart. I no need to manually apply that YML. And if you see the Prometheus, Grafana, all the third-party softwares, if you see a lot of third-party softwares like Grafana, Prometheus, right? If I want to run Jenkins also, I can install Jenkins also in a Kubernetes cluster using Helm chart. Prometheus, Grafana, all applications are available as a Helm chart, right? If I want to install some application, instead of writing the YMLs from scratch, instead of using the YMLs, I can use a Helm repository. Now, if you see metric server, suppose if I want to deploy metric server, I can deploy this metric server. As of now, do I have a metric server deployed in this cluster? As of now, if you see, did I have a metric server deployed? I want to see the pod utilization. I want to see the node utilization. Top pods. It's not available, right? So instead of last time, what I have done, I have applied lot of YML files. I have created a YML files. I have created a YML files. something like this. I have created a YML files, metric server. I have a lot of YML files. I applied all these YML files. Now all these are already, sorry, this is available as a Helm chart. Now I can install Helm chart, something like this. Now if you see Helm search repo, let me search, let me grep. I don't want to see all this. Let me grep. Now if you see, there is a chart available. So now if I want to deploy, guys, let me show what is going to be deployed. If I deploy this chart, if I install this Helm chart, what is going to be deployed? Let me show that Helm template, your chart name, what and all things it is going to be created. Guys, if you see what it is creating, if I install that Helm chart, the Helm chart contains all the YML files. Is it creating a service account? Service account and cluster role with all the required permissions, and cluster role, another role, and role binding, cluster role binding. Then service for your metric server. Then if you see your metric server application. So these are the things it is going to be deployed. These are the things it is going to be deployed. Now, if I want to install metric server, I can install using this Helm chart in the Kubernetes cluster. I can install using this Helm chart. How can I install? What is the command to install? Helm install. You can give some name. This we call it as a release name. Your application, what application name? Metrics server, something like this, or metrics server. Then your chart name. In your chart name. Now under which namespace it is going to be created, guys? Since I have not mentioned the namespace, right? Currently, our kubectl is pointing to which namespace? The default. So where our metric server will be deployed, under which namespace our metric server will be created? If I execute something like this, where this chart will be, basically where our application will be installed, in which namespace? Default. Suppose if I want to install in kube system, I can say something like this, -n kube system. Now let me install. Now if you see, Helm chart is installed. Helm chart is installed. Now if I execute Helm ls, why it is not showing, guys? We installed one application using Helm, but why it is not showing? That we deployed one application using Helm, but why it is not showing? Again, what is the namespace it is pointing as of now? This one by default namespace. We installed our application in kube system namespace. Now let me execute. Maybe I want to see in all namespaces. Now, do you see that there is one release, which one application which we deployed using Helm metric server? Now if you see kubectl get all -n kube system. So this one metric server deployed 75 seconds ago. It has created a deployment Deployment has created a replica set. Replica set has created a pod, and there is a service also got created for your metric server. How did it got deployed? We used Helm chart. Basically, the chart contains all the manifest files which is required to deploy this application. Which is required to deploy this application. Right? I just executed this Helm install metric server, the chart name. So this chart contains the templates for this application, metric server application. That this chart contains, templates as well as values, the default values. So it has installed the application. Helm connected to Kubernetes cluster, and it has deployed all the templates, all the YMLs, whatever we have in this chart. Now, if you see, now do you see that metric server is deployed and it's working now? So how did I deploy metric server application, that is third-party application, using Helm chart? And we can use Helm to deploy our own applications also, guys. We can use Helm to deploy our own applications. I can create a Helm chart, our own Helm chart. Suppose I want to create a Helm chart for our own application. I can use this command to create our own application chart, right? Let's assume my requirement is I want to deploy this application. Very simple application. Let me take Java web app. I already have an image. I want to deploy this application. I want to deploy this application. So in Kubernetes, if you want to deploy this application, you may need to create what and all objects you may need to create to deploy this application, guys. What we created so far. To deploy this application, what we need to create in our Kubernetes cluster? We need to create a deployment. We need to create a service. If required, if it is using PV or PVC, we need to create. But this is a stateless application. Are we using persistent volume claim when we are deploying this application? Are we using volumes for this application, guys? Are we using volumes for this one? So in that case, you no need to have a persistent volume claim. And if required, if I need to create a HPA, do I need to create a HPA, horizontal pod autoscaler, for this application? If my requirement is I want to have a HPA, automatically my pod should be able to scale up, scale down. What object I need to create in that scenario? HPA. And also, if I need to define my ingress rule, do I need to create an ingress resource? If I have to define an ingress rule for this application, do I need to create an ingress resource? Yes or no? Suppose this application I want to access using ingress, right? The host based routing, path based routing, if you need to define a ingress also. So we need to create all these files as part of your template. So if I don't use Helm, what we will do? You will create a deployment.yml, you will create a service.yml, you will have a hpa.yml, ingress.yml. You are going to apply all these YMLs. Same thing I can do in a Helm chart. In Helm chart also I need to define all these YMLs. But what is the additional features I am getting? The additional features, is basically it's hiding the complexity. It supports values at runtime, and we can maintain these charts in a repositories. Basically, this is kind of a package for your Kubernetes applications. It contains only Kubernetes YML files, nothing else. So if required, I can create a Helm chart for this application. How can I create? What is the command? Let me remove whatever I have, everything I will remove here. I have removed everything, nothing is there here as of now. I have a Helm CLI installed. Now I can execute, I can create my own chart for this application. Helm create something like this, Java web app. Your chart name, basically your application name. The moment I execute this command, do you see one folder got created? One folder got created. This is the standard directory structure of your Helm chart. This is standard directory structure of your Helm chart. It contains chart.yml, values.yml, templates folder, charts folder. This is the standard structure. Let me see if I have a tree. I will show this folder in a tree structure. If you see, the moment I execute that Helm create, it has generated a standard directory structure, right? If you see, it has a chart.yml. What is there in the chart.yml as of now? It contains information about your chart, version of your chart, right? Name of your application, description. Helm chart for Java web application, right? You can update this description, your chart information. So here, if I want to give Helm chart of Mithun Technologies Java web application, something like this. You can give a description. So the chart contains basically metadata, the metadata of your Helm chart, the chart.yml. Now what is there in the values.yml? Some default values will be there. You can add your own values. Guys, it has just generated a predefined directory structure. You cannot deploy as is. You need to modify based on your requirement. Now if you see, it has some values file. It has some values file. They are saying replica count 1. This is the image as of now. Guys, is this the image which I want to deploy for this one? This application, is this the image which I want to deploy? So what I have to do while creating a Helm chart? While creating your own Helm chart, you need to update all your values. If required, you can add your own values. Where are these values are being referred? Where are these values are being referred? These values are being referred as part of your templates. As part of your templates, right? So if you see, it has generated some files in the templates. There is a deployment.yml, hpa.yml, ingress.yml, service account, service. Suppose you are trying to create a Helm chart for Spring Boot application. If you're trying to deploy an application, that Spring Boot application using Helm chart, you don't have a basically PVC file, you don't have a stateful set. So you need to create your own templates. You need to have all your YML files here, and you can update based on your requirement. It generates basic directory structure. This generates basic directory structure. That's it. Based on your requirement, you can add your own templates, your own YMLs, and your own values, and create a Helm chart. Now let me show quickly, very simple. Now if you see the templates, deployment file, they are referring values. This is like one condition. If auto scaling is not enabled, then only number of replicas will be set. If auto scaling is not enabled, in a values file, there will be a one value, auto scaling dot enabled. If it is false, then only the number of replicas will be set, like it will be added. This is template. If you see image name also, if you see image name also, the name of the image, did they hard coded anything here? Your repository and your tag, did the hard coded image name, image tag, right? From where it is coming? It's coming from values file. It's coming from values file. Values.image.repository, values.image.tag, right? These will be rendered at runtime when you are deploying. Now, this is the default one. On top of it, if you want to customize, you can customize. Now, if you see, I am trying to deploy a Java web application. Is my container port is 80? Is my container port is 80? Can I use as is? Or I need to modify as per my application? Do I need to modify? Or can I use as is, as per my application, as per my requirement? They are just generating the standard directory structure, which we have to update. So let me update this file, because my container port is not 80. My container port for this application is 8080, right? If you want to have a health check, liveness probe and readiness probe, I want to have on this path, something like this. I need to update as per my requirement, the templates. Now, my values file, I need to update my values file also, because values file, if you see image.repository, there these values are being referred in the template. So this is my image Docker hands-on / Java-web-app. Now tag, if I leave it as is, what version of image will be deployed? What it will take? It will take :latest. And again, guys, at runtime also I can change this value. I will show that. I will leave empty here, but while installing a chart, I can pass at runtime also. Now, if you see, as of now, is auto scaling is enabled? Is auto scaling is enabled? Auto scaling enabled is false in a values file. So will it deploy that HPA object if this is false? Will it deploy the HPA object if it is false? If you see, auto scaling dot enabled is false, right? If you see the template, when this will be included? If you see, this is under one condition. This is under one condition. When it will be included? When it will be included, if your auto scaling value is true, if your auto scaling value is true, values dot auto scaling enabled. As of now, it is false. If it is false, will it include this object when it is installed? It will not, right? Now, if you see service also, service YML, they have not hard coded the port. They have not hard coded the port. The basically the service port and service type. From where values are coming? These values are coming from values file, and you can pass these values at runtime. And if you see ingress also, now ingress, when this will be rendered, if I have enabled the ingress in a values file, then only this ingress rule will be created. Ingress rule will be created. Otherwise, it will not be rendered. If you see in a values file, ingress, as of now, ingress is enabled is false, right? So if you enable it true, here you can define what is the host, what is the path, right? If you have to enable certificates, what is the secret name, for which host you are enabling the certificates, right? So these values, if you see, these values has been used here. If you see the path is coming from these values. The host is coming from also that values file, from that values file. If you see the host is also coming from here. So you can define everything in a YML that you can deploy. Now, as of now, I have just changed. Now let me show that Helm before installing, right? I can show what and all files it will be generated. Helm template, you can refer local directory name also, not only repository, you can refer local directory name. Now what and all things it is generating, guys? What and all things it is going to be deployed? It is going to create one service account, even though we are not using, but that is fine. Service of type cluster IP. And if you see deployment, but from where, guys, this version is from basically the API version, like chart. Okay, I need to update that one. In your, there is a file called chart.yml, right? Here, this is taking as a tag by default if I don't pass. Okay, so I need to update this one. App version, basically it's taking from here. So my app version, if I give something like this, one, it will take version 1 image, 2, 2, 3, 3. But again, this is the default one, right? You can change latest, I can give. Now let me render the template. Now you can see image name as :latest. Otherwise, I can change in the values file. Now, since in values file it is empty, it is taking from that chart.yml. If I provide something here, now this will be taken. Now you see this one. And also while installing or while generating, I can change at runtime. Now do you see? In my values file, I have version 1, but while installing, I can use this option. So did I modified my templates, or I am playing with my values? Do I need to modify the templates every time Once I generate a template, do I need to modify for every deployment which I want to do if there is a change, or can I play with values? I can play with values. If you see, if I use this option while installing, what version of image will be deployed? This version of the image. If I don't pass, whatever is there in the values file, whatever is there in the values file, you can see. Now I can deploy my application, something like this, from a local folder also. Helm install. Yes, before that, kubectl get all. Maybe let me delete whatever is running. Let me delete whatever is running. Okay. Now I can install using this chart, local directory also. I can install this application, something like this. Helm install Java web app, the directory name. Now if you see kubectl get all, who created, how I created this deployment, how I created this replica set and service, right? With the help of Helm chart, right? So this Helm chart we can maintain in a GitHub also. You can maintain this complete for directory structure in a GitHub as part of your CI/CD. When you clone, you will get your Helm chart directory also, and you can pass values in your CI/CD using Helm. In your CI/CD, you can execute Helm install your chart which you have maintained in your GitHub, and you can pass the build number, whatever image you have generated, whatever value you have to pass, you can pass at runtime also. So today we just generated a Helm chart, and I have not, I can package this Helm chart as a tar file, and I can push to our own repository, guys. So today I just created a Helm chart. I deployed Helm chart using local directory. If required, you can package this Helm chart as a tar file, and you can maintain in your own repositories. And you can deploy from the repository also, that we will discuss tomorrow, guys. Once we discuss this Helm, how to maintain the chart in the repository, then we will try to discuss about Prometheus and Grafana. We will use Helm to deploy Prometheus and Grafana. Tomorrow we'll continue, guys. Try to go through this document which I am going to share, and try to create a Helm chart for one simple application. We'll continue tomorrow. Thank you.